All right. So here you go. We are going to solve a system of equations. So yesterday I gave you an assignment where you filled in the matrix, right? With numbers. Remember that second one I said super easy. You just copy the numbers down, right? Well, in this scenario, we're actually going to solve the equation. Here we go. First thing you need to know is actually this right here. And just you don't need to write this part down, but let me walk you through it. All right, let's say you have something like this where a certain matrix, I wanted a highlighter. You have a certain matrix times a vector equals another vector. That's what's going on here. Matrix times a vector equals another vector. All right. What if you wanted to solve for this, which is what we're going to do here? We're going to solve for this thing. Well, if you were solving an equation, normally you would say something like this. AX equals B. You'd say, if I'm solving for this, what would you do? You'd divide by A. The problem is, and I hinted at this a different day, you can't divide with matrices. You can't. You can't do it. All right, so down here, this is a question from your assignment. It says, what did they do wrong? Well, right here, you can't divide by a matrix. And the reason is this: division isn't defined. We can't divide by a matrix, but you can multiply by its inverse, right? You can multiply by its inverse, but you cannot divide. There's no defined way to divide, so we have to multiply by the inverse. It'd be like saying, instead of dividing by 2, we are going to multiply by a half, right? It's the same idea. So right here, what we're going to do is we're going to multiply this by the inverse of A. So when we move this over here, quote, move, we multiply by the inverse instead of divide. Now on these, they actually give you the inverse. So the only thing really left to do is to take this matrix times that matrix. I'm going to do that right now. I'm going to move this up here. Inverse of A, let me copy it down. 11, 1, 7, 3, 0, 2. And then yesterday we worked on actually multiplying these, right? So if we take this row times this column, we'll get an answer. Are you ready? Let's do this together as a family. All right, so this down here is going to be B times inverse of A, which is actually equal to this, right? That's what we're solving for. All right, if I take the first row times the first column, what's the issue with that? -4 times 11 plus I can't, can I? Can I do it in this order? Remember how we did this yesterday? This is a 3 by 1. This is a 3 by 3. The only way you can multiply two matrices is if these two numbers are the same. But if I change the order, it will work. If I flip it around and I say inverse of A times B, it will work. All right, so let me just do this. Let me screenshot this and we'll make a new slide. Save me a little bit of time. There we go. If I do it in this order, it will work. Where this is the inverse of A. and that's B. We're going to multiply. All right, now, this row times this column. That row times that column. We're going to end up with 11 times negative 4 plus 1 times negative 2 plus 7 times 3. Let's go ahead and simplify that. What's nice on these is you know what the matrix should end up like. Here's what I mean. You're going to end up with that. Your answer is going to be just one column with 3 numbers in it. Okay? So right up here, we had 11 times negative 4. That's negative 44, right? Negative 44 plus negative 2, that's negative 46, plus 21, negative 25. There we go. And then move this row down. Times the same column. 3 times negative 4 plus 0 times negative 2 plus 2 times 3. If I add those up, I'll get negative 12 plus 0 plus 6. So negative 12 plus 6. Repeat one more time. 1 times negative 4. Negative 8 times negative 2. 3 times 3. So that's negative 4 plus positive 16. 12 plus 9. 21. There's my answer right there. That's X. That's Y. And that's Z. Bingo. Okay, so lesson is, first of all, we have to do it in this order. Otherwise, it's not going to be possible. Okay, and we're going to multiply by the inverse. Second kind of question you're going to see is a lot like this one, except notice here they gave us the inverse. Guess what we're going to have to do? Find it. So here's one where it's a 2 by 2. So this is like 2 assignments in one. So if I want to solve, and if I want to take A inverse times vector B, I have to figure out what A inverse is. See ya. You remember how we did that? Let's find the inverse of A. Inverse of A. The first thing was we switched the top left and bottom right. 4 and 2, we switched them. That's right, we switched the signs on the others. So now it's positive 3, positive 1. And there was one other step. We have to find the determinant with the original numbers. Some people kept messing that up. They were doing the determinant of the new matrix that I had over here. The determinant is 2 times 4 minus negative 3 times negative 1. So that's 8 minus 3, which is 5. We're going to take 5 and do this on every single one of these. That's our inverse. So now, A inverse down here is that matrix. I'm going to copy it. Oh, geez. Come on. Nope. Nope. Ugh. What the heck? All right. Let's just undo that.
Yeah, how would you do the inverse? I guess.
Of a what?
3 by 3.
We're not going to do any inverses of 3 by 3.
Okay, the
That's a little more complicated. Yeah, that's why they gave us that one. It's a little more complicated. All right, remember we have to do it in that order. So now we're going to take the first row times first column. So 4/5 times -2. Ugh. Plus 3/5 times 11. Oh, that's gross. Let's be exact. Let's not use decimals. All right. So that's going to be -8/5 plus 33/5. You can combine those because they already have the same denominator. It'd be 25/5, wouldn't it? 25/5, which is 5. That's nice. Thank you, Con. Yeah, thanks, Con. Now let's do it again, and then we'll be done with the second row. So 1/5 times -2, 2/5 times 11. So this is -2/5 plus 22/5. 22 minus 2 is 20. 20/5 is 4. Voila. If you wanted to check your answer, you could take the original A matrix times your matrix, and you should end up with this matrix. You could do that if you wanted to check yourself. Okay, so not too bad. Don't forget it has to be in that order that we talked about. You might have to find the inverse like this. Thank you.